Hi, I'm Carson Swollen. I'm an intern at Deephaven Data Labs, and today I'm going to be covering my thought process for designing what is probably my favorite part of the new Deephaven Go client, the query graph system. We're going to build up that interface from the beginning using some criteria I've outlined, and we're going to cover a few different topics related to creating good APIs in Go. But first, we have to ask the question, what exactly is a good API? For now, I'm going to reduce it to three parts. The first is completeness. All of the important functionality of your product needs to be usable and available. The next one is expressiveness. Your API shouldn't make your product harder to use. If your product is complicated, it's okay if your API is complicated too, but it shouldn't be more complicated than it already is. The third criteria I'm going to choose is debugability. This is an unusual one, but it's important because stuff happens and you want your user to be able to figure out what happened when it does and then fix it. If you have all three of these together, then much like having all three pieces of the Triforce, then you can take over the world. Well, maybe not quite, but you might have an API that's fairly usable. So let's see how I designed the query graph interface with these three criteria in mind. So our actual problem is that I have some references to Deephaven tables in my Go code called table handles. I want to be able to issue some requests to the server that will perform some operations on these tables and give me some other tables. So tables that have been sorted or filtered or truncated or joined, whatever. These requests all go over the network and they have some syntax checking in them that could be invalid. So we need to worry about errors for all of them too. And all of the tables that we create ourselves need to be released at some point to free up server resources. So we have to keep that in mind too. So if we were to design an interface that allows us to do that, well, the simplest possible option we could do probably looks something like this code. So we have one function per table operation. Each function can return an error, or if the network fails or your syntax is invalid, something like that. And we can release the table once we're done with it. So we have the function in the first block, the second block is our error handling, the third block is our table releasing. Great. That's simple, that's straightforward. So let's see how this scales to more operations. So surely 4 table operations seems like a pretty small amount. That shouldn't be too unreasonable, right? Well, oh no. Oh no. Oh dear. Okay, so we just want to do 4 table operations, and already we have code split across 2 slides, which is terrible because that means that when you're looking at your code in an IDE, you have to scroll up and down, and you have to context switch between different pieces of code, and that makes it monumentally harder to understand. And not only that, but we also have our business logic, our actual series of table operations mixed in with the error handling, mixed in with the table releasing, mixed in with the who knows what, which is mixes priorities in a way that just isn't very conducive to making code readable at a glance. So we can lay out why exactly this is bad by evaluating it using our criteria. So it is complete. It has all the features in it. It is debuggable. If an error occurs, we know which function call gave us the error, but it is not expressive at all. It is incredibly verbose. It is way more complicated to use than the actual interface should be. And if we were to try to use it right now, we would end up like Bart here, trying to write if error not equal to nil, return nil error. at least 3 dozen times. That's not very pleasant. So, what can we do to solve that? The first thought might be, well, remove the error handling or the table releasing, which would make it much more concise. But then our application crashes if there are any errors and leaks server resources. So now our interface is no longer complete. So we can't do that. However, we can steal some ideas from other languages or programming patterns. So in this case, I looked at some Java code and at a little bit of Python code, and I found something along the lines of the builder programming pattern. It's simple, but applicable here. So here's the idea. Our function calls don't actually execute network requests. They create a query graph, which is essentially a list of the table operations to be performed. It doesn't do them, it just creates the list of things to do. Then we have a function that can execute every operation in that list all at once. We can execute the entire query graph in one place, and we can handle our errors in that one place and release our tables in that one place. So the idea is that this should separate our business logic from the minor details. So if we were to write that up in code, it would look a little bit like this instead. As we can see, it now fits on one slide and is also significantly more readable. So the first block of code constructs our actual table operations, which is our query graph, and that's the only thing it does. And we can see at a glance that it does a filter, it creates an empty table and updates it, and it does an as of join. This is the same 4 table operations that we did before, but it now fits in much less code. Then the middle block actually executes our query, and you can see that we can handle the error for it in one place. We only write it once. Then the last block is where we release any tables that we don't need once they're no longer needed. So this separates all of the things that we need to do into nice blocks and reduces the amount of code we need to write while not losing any of the functionality. Well, with one catch. So this interface is complete because it has all the features. It's expressive, it's simple, easy to use, and it's not any more complicated than the actual idea of manipulating tables. But it's not very debuggable. We now have one big blob of table operations, and if something goes wrong, it's very difficult to know where in that big blob it happened. Good luck finding it if you have 24 table operations. So the solution to this is actually pretty simple from a user perspective. We just give it better error messages. So we can print out a full traceback of which query operations led up to the one that failed, so we know where in our query graph the problem is. And we can see here, by looking at the last line of our traceback, that we've probably typoed the word magnitude in our as of join, and that's why we got an error. We don't have to search through the whole graph. So if we take all of this together, we can see that finally we've satisfied all 3 of our criteria. It is complete, it has all the features we want, it's expressive, it's easy to use, concise, and not any more complicated than the actual product, and it's debuggable. We can see where our errors occurred and fix them or handle them. Now, of course, that doesn't necessarily mean that we're done in all cases, but it's a pretty good smoke test. Now, these aren't the only criteria that are useful. There are other criteria you might want to consider depending on your application, what you're doing, what your requirements are, your programming language, whatever. But taking a more structured approach and picking explicit criteria is often quite helpful. And I think this example also demonstrates how you can leverage patterns that don't necessarily seem very related to construct interfaces that are much nicer to use than the straightforward approach. And the last thing I'd like to say is that if you would like to try out the Go client, it's available as a package right now. So you can try out the query graph and all the other related features for yourself if you would like. So hopefully some of this work can help guide future work with APIs in Go or in other languages. And that's all I have for today. So are there any questions?
So this was your first experience with Go, and what you discussed here was kind of the forced error handling that Go will make you do. Were there any other interesting Go artifacts that made you change how you thought about this, or maybe how someone would use it?
About this interface specifically, just
Well, not necessarily this interface, but the client.
there were a few things, like in particular, that whole table releasing thing. I did, if this were a language like C, I would be very, very worried about having people manage their own tables. But in Go, the fact that there is defer and you can schedule that function call to be run at some specified other time, kind of eased the pressure off on that a little. So I had to think about it less, I suppose. So, it's a bit of a double-edged sword. There are some things that make that significantly make things harder to use, and there are some features that do make it a lot easier.
Right. Any other questions? Right. Thanks. Nice job, Carson.